All right, so worksheet 2 is verifying identities. This wasn't up at the beginning of class, so probably most of you didn't see, but there's still 12 people have to take the last quiz, so I have them graded. You can look at them after class. You can stay after and make corrections and retake anything you want to do, but I'm just not physically handing them back until at least a few more people have taken them, okay? So if you want to get your grade replaced because you want to do a retake, you can come in and do that. All right. Verifying identities is pretty much what we were just working on when we were doing the simplifying. The only thing is, in my mind, they're easier in theory because they tell us what we're supposed to get down to. Okay? So they give us the answer. But because it's called a verifying problem, you can only work with one side. So you need to take one side and make it look exactly like the other side. And the whole thing is you got to show all the steps. Okay? You can't just guess at the end because I'm giving you the answer. So it's all about the steps. All right, so one more time, clarify, you can only make changes to one side of the equation. If you change both, you won't get any credit. All right. This is an example you have done on your notes. It's kind of interesting because they worked it out by changing secant squared minus 1 to a tangent squared. Does everybody know where to find that? Because last hour they thought I was just doing magic. Do you know where to find that, guys, on the Pythagorean identities? Okay. It's on this blue sheet at the top, but you have to rearrange the middle one. Okay. See how it says 1 plus tangent squared equals secant squared? Well, that means if you move the secant squared minus 1 over the minus 1 over the other side, you'd get tangent squared. Everybody okay? Anybody lost? All right, then they changed everything to sines and cosines. Then it says divide, so they flipped over and multiplied by the reciprocal. Then, because they were multiplying, they could cancel things, and they got sine squared. I realized a little bit earlier today that it would have been really easy to do this question because remember we talked about this, a plus b over a is a over a plus b over a. So if I made this secant squared over secant squared minus 1 over secant squared, what's secant squared over secant squared? What is the reciprocal of secant? No, cosine. So 1 over, this would be 1 over secant squared is the same as a cosine squared, and 1 minus cosine squared is sine squared. So I'm thinking that would have been a little bit easier way to prove that one. Okay. Notice what I was doing was working with this messy left side to get it simplified down to a sine of x. All right. Let's try this one. And some of these are messy, guys. I'm telling you now. All right. I'm thinking I would like to work with the left side because I think it's easier to get rid of a subtraction than it is to suddenly come up with a subtraction. Okay. So I'm going to leave the right-hand side alone, and it's somewhere at the end of this problem, I need it to say equals sine times tangent. All right, what do you want to start with? Change it to sines and cosines. So secant would be 1 over cosine minus cosine. Yes. Then we're going to need a common denominator. So I'm going to show that I'm multiplying by cosine over cosine here so that I will get a common denominator. Some of you get stuck on these because you don't get fractions, right? When you just have just cosine, it means cosine over 1. All right, so this one stays 1 over cosine, or the common denominator is now going to be cosine. But if I want to write it in a few less steps, what did this become? Yes, so it's 1, well, it is going to be sine squared. It's right now 1 minus cosine squared. Do I need to keep writing it separate steps? Or are we okay? You could have put a step in there that said 1 over cosine minus cosine squared over cosine. Then written this step, but I'm okay if you just write it with the common denominator right away. All right, what is 1 minus cosine squared? Over cosine. Now, you need to show me how that becomes sine times tangent. Yes, if we, right now it says sine squared is really sine times sine, right? And it's all over cosine. So since it's multiplication, can I just do that? However you want to explain that, but it's sine times tangent. Now, a lot of teachers will make you write, either rewrite what it's equal to down here, or write equals. Anybody know what that stands for? Right-hand side, okay? So we just made the left-hand side equal the right-hand side. And I really don't care if you rewrite that down there, or if you just put a big check mark. Yes, I got it to equal the other side. I'm so happy, I'm excited. There we go. Okay, however you want to do it to show that you did make it equal the other side. Okay, I don't know about you, but I don't know how to trade a secant in for that gobbledygook. So I'm thinking this time we need to work with the right-hand side, yes? Yeah, okay. What do you want to do to the right-hand side? You want to make those sines and cosines first? Say what's tangent, guys? Okay. Plus cotangent is? We don't know these yet. It makes everything 3 times as hard and complicated, right? Got to look up every little trade. All right. Do you want to distribute or do you want to get a common denominator first? It's going to be the same number of steps, I think, either way. But if we multiply, this will become sine squared, but still over cosine, right? Plus, what's going to happen back here? Yeah, I got a cosine. I'm multiplying it by a sine, and it's over a sine. Can I just cancel that? Okay. But what do I still need to be able to add them together? A common denominator? So this is now just over a 1. So what do I need to multiply it by? Cosine over cosine. So this one is sine squared over cosine still. But what is this one now? Now I wrote it separately, but you can combine them all over one common denominator, right? And what will this numerator become? That's a Pythagorean identity. And it is equivalent to 1. And when you add fractions, you just keep the denominator, right? You don't add them together. And the reciprocal of cosine is? I am not going to take off points if you forget all the little thetas or x's or t's. Or like me, if you switch in the middle of the problem from x's to thetas or something. Yeah, I'm good at all of the above. Everybody okay? You're good. Yes. Okay. If we had done the common denominator first up here before we distributed, okay, it would have been, you would have had to multiply this guy by sine over sine, okay, and this guy by cosine over cosine. So then you would have had sine squared plus cosine squared all over a cosine times a sine. I skipped too many. Okay. So then this becomes a 1. So you have sine times 1 over cosine times sine. And that's all multiplied together, right? Everything is multiplication. So we can cancel the sine then, and we just get 1 over cosine. If I was, I would have taken just as many steps because I wouldn't have bothered. I would have written it out nicer than I did. But since we were, okay, let me get rid of that. So when I print this, it's not on there. I'll be so confused. Okay. All right. Everybody should be able to do that one. It's all multiplication. It says everything should get down to 1. So it should just all cancel, right? Okay. There are 2 questions on Friday's quiz where you have to verify. One of them is mostly something like this, where you just have to simplify and cancel, okay? One of them is one where you have to get a common denominator, okay? It's not a horrible common denominator problem like this one, okay? But you do have to get a common denominator. All right, which side would you like to work with here? The left? Okay. Actually, I have a really good, I'd like to show you, before I do this question, help me review this idea. When you have a complex fraction, something like that. We did this earlier this year, I think, but you do it a lot in calculus. What is the common denominator for this whole, all 3 of these little pieces here? 2x and y, right? Okay, if I multiply a 2x and y onto the top and a 2x and y onto the bottom, we will get rid of the complex fraction. We won't have all these fraction in a fraction anymore. Here the 2 would cancel. I'd have 1 times xy. When I distributed and multiplied it over here, what would cancel? X, so I'd end up with 2y. When I multiplied it here, y would cancel and I'd have 4x. Do you see how slick that is? There's no more complex fraction, okay? So that's the idea we're going to use on this disaster. All right, so what is the top? 1 over sine. Cotangent is cosine over sine. And tangent is, okay. What is the common denominator that we would need to get rid of all of those fractions at once? A sine and a cosine. Does everybody see that? Okay, so I'm going to multiply a sine and a cosine onto the top, and a sine and a cosine onto the bottom. Now, when I do it onto the bottom, I have to remember I'm doing it to both things, like I'm distributing it down there, right? So I'm actually going to write it over here. As well, because I'm distributing it. Okay, what happens on top? Yes, because everybody understands this was just over 1, right? Okay, so we just have cosine on the top, no more fraction. On the bottom, when I distribute it to this piece, what happens? The signs cancel and we get, and here, the cosines cancel and we get, this is a Pythagorean identity that equals 1. So we just have cosine of x over 1, or cosine of x, which is equal to the right-hand side up above. So what looked like a horrible question wasn't as bad when we did that. Okay, so was a complex fraction, meaning fractions over fractions, with adding and subtracting, okay? The reason, guys, you cannot flip this over. Someone's going to think, oh, I just need to flip those over, right? But until it's a single fraction, you can't. Let me give you another example. If I have this 2 divided by 1/3 plus 1/5, is that the same as 2 times 3 over 1 plus 5 over 1? No, I can't just flip that over like that, okay? Not even close. All right, moving on. What do you want to do here? Crying is not an option. No crying in pre-calc. We need a common denominator. Yep. Go ahead, Sarah. So this one needs to multiply by what so that it has a common denominator? Sine y plus 1 over sine y plus 1. Then there's a big minus in the middle. We got to watch that. Sine y plus 1 is going to have to multiply by. You cannot separate anything when it has a sum in the denominator. If you had this 1 plus 2 over 3, it is not the same as 1/2 plus 1/3. Okay? Everybody clear on that? Unfortunately, right? Okay, so 1 times sine y plus 1 is just sine y plus 1. Now she's distributing back here very carefully. -1 times sine is minus sine, but -1 times that -1 is plus 1. Oh, that's looking like a 2 up there. I needed a 2. Okay, the denominator, I'm going to write this out one more time. It's the common denominator. What are we going to need to do with that, though? Multiply it all together, FOIL it together. If we had a y minus 1 times a y plus 1, we'd get a y squared minus 1 when we FOILed it all together, right? So this is going to end up with a sine squared y minus 1 in the denominator. What happens up top? Sine minus sine is 0. 1 plus 1 is 2. Okay. Then I need a identity for sine squared minus 1. But what I know right now is this. If I subtract a 1 over to this side, I have sine squared minus 1 equals, what am I going to have to do with that guy? Everybody okay that you'd subtract it back over the other side and it'd be a negative cosine squared? So I have 2 over negative cosine squared. I don't know where my y went. It just became a theta. All right. How does that equal what we had left? Well, can I move the negative to the top if it's just hanging out there? So I have a -2. And then what I really have here is a 1 over cosine squared, which is a -2 secant squared, which is what the right-hand side said at the top. I should have been going down, but I was running out of room. Yes, no, got this one? All right. I yeah. If you just want to watch and not even write this one down, because I promised this would not be on a test or quiz. Did you do it? But okay, what I did, shh, guys, I don't know, maybe Sarah did something different, but I distributed it together. So I have sine x minus cosine of x. Then this is multiplication, right? So what do I get if I multiply that times a sine? Sine squared times cosine. Okay. Now when I multiply a sine cosine times a negative cosine, I get a negative sine and a cosine squared, whatever order you want to write that in. Okay. Now, this is where most of you would have got stuck. What did you do, Sarah? You started with the other side, so you factored it using cubics. Do you remember the rules for factoring, guys, cubics? The factoring rule says you take the cube root of each, right, and keep the sign. Do you remember then? Then what? You take square the first one, put them both together, but change the sign. And then you square the last one, which becomes plus cosine squared. Okay, was that much easier? Because what's a sine squared plus a cosine squared? Nobody would have remembered the cubic rule, unfortunately. So she got this to equal the right-hand side. Okay, back up what I did this was not as good as her way. But if you took these two and you put them next to each other, sine x minus sine x cosine squared plus, and you put those two next to each other, negative cosine x plus sine squared cosine. Then, yeah, I got lost because I wrote too much stuff here. But you take out a sign here. I'm grouping, guys, is what I'm doing, but I'm rearranging the order. So then I have 1 minus cosine squared. And what is a 1 minus cosine squared? A sine squared. So I ended up with a sine times a sine squared, which is a sine cubed. Okay. These two, if I take out a negative cosine, I'll have 1 minus, yep, 1 minus sine squared. 1 minus sine squared is okay, I lost a lot of x's there, and you get cosine cubed. That's a 3. Okay. Sarah's way was better. Not afraid to admit it. Either way, I do solemnly swear it's not going to be on the test or quiz, okay? Yeah. Okay. This one is messy as well, but we're going to do this one. Okay. What's tangent? Plus a, I assumed you wanted to start with the left-hand side. I always start with the messy one, try to simplify it. Okay. Which got me in trouble on the last one, but common denominator, yes, unfortunately. Okay. So this needs to be multiplied by 1 plus sine over 1 plus sine. And this needs to be multiplied by cosine over cosine. Okay, so distributing up here, what do I get? Sorry. Sorry, people watching the video whose ears were just blown out. Okay, sine times 1 plus sine times sine is sine squared. Cosine times cosine is cosine squared. All over the common denominator, which I'm not going to multiply together. Then what? We're allowed to take only part of that and trade it for something? When we're adding, yes. We can add in any order we want. So sine squared plus cosine squared is 1. So we end up with a sine plus 1 all over a 1 plus sine times a cosine. Why am I allowed to cancel that? Because, well, we're canceling the whole quantity, right? It's an addition, but we're canceling this addition down here that is now being multiplied by cosine. So we end up with nothing, otherwise known as 1 over cosine. 1 over cosine is secant, which was the right-hand side or the left-hand side above, right? Okay. That was kind of gross. I still don't think, there is the one where you have to get a common denominator, I don't think is quite that bad, but is this the same question, like different gobbledygook? You do the same thing, right? Almost exactly. We'll see if we have time. I want to cover the next section. I may come back and do that one real quick. The next section says you can graph these to determine if it is an identity. If I ask you that on a test or quiz, is this an identity? You can go ahead and graph it. Otherwise, I'm just going to say simplify this identity. So you don't need to bother because I'm telling you it is an identity, okay? On the homework, it says, okay, I'm kidding. It says here, it says it on the assignment sheet. It says you have to do 34 through 36 all, but you just have to say yes or no, okay? I graphed it was an identity, or I graphed it and it wasn't an identity. These particular ones on the notes say graph it. If it's an identity, verify it. If it's not, find an X value for which it's not equal. Okay, all I'm saying is you just write yes or no. Deal? With that in mind, how would you type this in to see if this is an identity? Okay, what would you put in Y1? There's no cosecant button. 1 divided by sine of x minus sine of x. Now, you can put extra parenthesis here, but you don't really need it. Yes. Because it's always going to divide before it subtracts, right? Calculator. Okay, y2, how do you put in cotangent? I would just do 1 over tangent. You can do cosine over sine. It'll work. Oops, then it's times cosine back here, right? All right, and then you have to see if it's an identity. I don't think I put this one in my calculator. There, they did it over here. They show that it works. Okay, rather than skip the verifying part, this is actually a really good question that I would ask you on a test or quiz. So can we verify this one with a little note to yourself that it might be one that's on a quiz? I don't know that it is. It's already verified for you, I think, on your sheet. But let's talk about it. Cosecant is what? Just help me. 1 over sine, and then it says minus sine. Then what? Common denominator? So we got to multiply by sine over sine here. Whoa. Okay. So you get 1 minus sine squared all over sine, which is, what is 1 minus sine squared? Then this is really just cosine times cosine, right? and it's all over a sine. Well, one of those is a cotangent, yes. There's a cosine left. I don't know what just happened. It's here. I don't know what I did. You don't have this question, or it's worked out for you? What? No, you, oh, they worked with the right-hand side. They did the right-hand side instead of the left-hand side. Okay. Oh, they just wrote it out funny? Okay. Anyway, moving on. Number 9. I don't have much time left. They just, okay. To the right. Okay. This problem I have on my calculator here. It says sine plus cosine times cotangent, which I did 1 over tangent. And then it says 1 over sine. I just wanted to show you that it helps if you go to the second one and you go to the left and you do one of two things. You could pick the thick. Do you remember how you can hit enter and then it gets, instead of a thin line, a thick line? Or you could pick the little bouncy ball. Do you remember the bouncy ball thing? Just for this one, I'll pick the bouncy ball. And then you wanted 2 things whenever you graph in trig. What do you have to do? Radians and zoom trig or set your window to something, yes. So I'm going to go window, or no, I'm going to go zoom, trig is choice 7. Okay, watch closely because it's graphing Y1. I don't have a color one on my new computer here. Then it's going to go back and graph Y2, and you will notice that little bouncy ball is showing you that it's tracing over exactly the same places. Do you see that? Okay, so is this a yes or a no? This is a yes, okay? Actually, I might go back and prove this one too if we have time, but number 10, how do you type cosine squared in your calculator? Well, if you have the new operating system, it will let you type this, okay? The old operating system, you had to put extra parentheses in because the thing is, it's not just squaring the x, it's squaring the whole function. So I always type it with the extra parentheses. Now, I want to show you, I did this. Just kidding. All right, this time I'll use the thick one to show the difference, but they're actually not equivalent. All right, because it would be 1 minus cosine squared is sine squared. 2 shifted it up 1, it's not the same. So you just need to write no. The part where it says find a value, well, you could pick anywhere basically, but if you set it 0, they're not the same. You don't have to do that anyway in the homework. All right, I'm going to go back and verify this question. This is another one that would make a really good test question, okay? If you had sine x plus cosine x times, what do you want to trade for cotangent? Now what do you have? Sine squared plus cosine squared over sine. You get a common denominator, sine over sine, you'd have sine squared plus cosine squared all over sine, which is what? 1 over sine, which is cosecant, which is the right-hand side. Do you see why that would be a really sweet one for a test or quiz? Well, it requires you get a common denominator. The common denominator was nothing horrifying, right? Okay. So when I say there's one on the quiz that has simplify, with just like some canceling, and one where you have to get a common denominator. It's probably something kind of like this, where the common denominator isn't miserable.